Hello, Algebra. Alright. Looks good. Looks like we're focused. Okay, so we're going to talk about 2.3 again, but I'm calling it 2.3b, right, because we're going to be looking into it further with applications, okay? So how we can use solving multi-step equations in different ways. And we're still working on standard B, just so you know. So we're going to talk about consecutive integers to start. Okay, so what are consecutive integers? They are integers in counting order. So, well, first of all, what is an integer? So integers they include 1, 2, 3, your counting numbers and so on. Okay, they also include the negatives of those. So -1, -2, -3, and going more negative. And then also 0 as well. Okay, it's a little hard to see for some reason. Okay, I will do my best throughout this. Okay, so examples of counting integers. Okay, so of consecutive integers, so integers in counting order. That would be like 1, 2, 3, 4. Those are consecutive integers. -20, -19, -18. Those are also consecutive integers. Okay, they're integers in counting order. All right. There's a way we can represent consecutive integers using symbols. So we can represent any set of consecutive integers with symbols. So n is a variable representing an integer. All right. So n is our starting integer. Consecutively, the next integer is the quantity n plus 1. And then the third integer is n plus 2, the fourth n plus 3, and so on. So why do we write it like this? Well, think about if we're starting at 1, then our first integer n is 1. Our second integer is n, which we said was 1, plus 1. Our third is 1 plus 2, our fourth is 1 plus 3, and so on. Okay, what's 1 plus 1? Well, that's 2. 1 plus 2, 3. 1 plus 3, 4. Okay, these addings are telling you how far out we're going from our starting integer. Okay, so that's consecutive integers and symbols. We're also going to talk about even consecutive integers and odd consecutive integers. So some even consecutive integers would be 2, 4, 6, 8, right? Numbers like that. You're counting by twos, like -14, -12, -10. Okay? So how we would write that in symbols is we're not going in counting order, right? We're not talking about the number that comes immediately after. We're talking about skipping a number. Okay? So you start with an even number. Okay? That even number we'll call n again. Okay, the next number, well, it's not the one immediately after that because that'll be odd. So you got to go by twos. Okay, so when we're talking about consecutive integers that are even consecutive integers, we write it like this. So n is even. All right, for odd, we actually have the same symbols. What do you think is different though? It's that starting number. We have to make sure we're starting with an odd number. N is odd. Okay? So just want to talk about that a little bit and then show you how this is applicable using multi-step equations. So some examples. Sorry, I added in some things here because I had missed it while I was writing. So first example, find 3 consecutive odd integers with the sum of -51. So with our odd integers, okay, we need to find 3 consecutive odd integers. All right, so we have n plus not 1, 2, and n plus 4. So those are our 3 consecutive odd integers with a sum. Okay, so that means we're going to add them. So let's put in some addition symbols. A sum of negative 51. Okay, so they add up to negative 51. All right, what do we do? All right, so with these groupings, there's no number up front here, so there's no distribution we really need to do. So we can really just write this as n plus 2 plus n plus 4 equals negative 51. All right. Well, we have some like terms, right? We have 1, 2, 3 n's. So if we add those together, we get 3n, right? And then our 2 and our 4, 2 plus 4 is 6. All right, now that looks like something we're used to. Let's solve for n, right? Okay, so we're going to subtract 6, right? We do PEMDAS in reverse order. So subtract 6, that'll cancel, and we have 3n equals negative 51 minus 6 would be negative 57. Okay, and then I'm going to divide by 3 on both sides to get n alone. Get n equals negative 57 divided by 3. You can use your calculator for that, but I believe it's negative 19. Negative divided by a positive will always give us a negative, so I knew it was negative, but I'm pretty sure it's negative 19. All right, so does that answer the question? Well, it says to find 3 consecutive odd integers. Okay, well, we said consecutive odd integers are n plus 2, and n plus 4, right? Right, well, we found n. So we found our first consecutive odd integer, negative 19. But what about our other ones? Well, we plug in n for these n values. So negative 19 plus 2, well, it's negative 17. So that's the other one. And then plug in negative 19 again. So negative 19 plus 4 is negative 15. You can use your calculator for this if you need to, okay? All right, so let's make sure it makes sense. Are they odd integers? Yeah, those are all odd. Are they consecutive odd integers? See, negative 19, negative 18, negative 17, negative 16, negative 15. Yeah, they each only got one number in between them. So they're in counting order. So yeah, those are our 3 consecutive odd integers. So I encourage you to pause here and try this one. Notice though, it says find the least of 3 consecutive integers with a sum of 33. Okay, so you just want to find the least, so the smallest of those integers. Okay, and it's consecutive integers, not consecutive odd, not consecutive even, but consecutive integers. So pause and try it. Okay, let's work it out together. So 3 consecutive integers. So that would be n plus 1, and n plus 2. Okay, with a sum, so I know I'm adding them, of 33. All right, so again, there's no distribution. I'm not going to rewrite it again. I'll just do n plus n plus n is 3n. And 1 plus 2 is 3. All right, so I combined all of my like terms. I got 3n plus 3 equals 33. Okay, this looks like something we've done before. So PEMDAS in reverse order. So let's say I'm adding 3, so I'm going to subtract 3. Do it on both sides. Keep things even. Those reduce, those cancel. And I have 3n left. 33 minus 3, well, that's 30. Okay. 3n equals 30. I need to get the n by itself. So it's 3 times n. So I'm going to divide by 3 to cancel that 3. Divide by 3. So n equals 30 divided by 3, which is 10. All right. Do I need to go back and do this process of finding all of them? No, I don't. Okay. So I need to find the least of the 3 consecutive integers, right? I know that n is the least of them, right? Because n is the first one listed, and then we're adding every single time. Okay, so we're increasing every single time. So the least of 3 consecutive integers with the sum of 33 would be 10. All right. Hopefully that wasn't too quick for you, but I want to be able to get on to some word problems. Everyone's favorite. I know. Okay, this first one shouldn't be too crazy difficult. So it's 12 decreased by twice a number is negative 34. Find the number. Okay, so we need to take this word equation and make it into a mathematical equation, right? We need this in numbers. So 12 decreased by twice a number. Okay, so 12, that's number 12. Decreased by, that's subtraction. Twice a number. So twice a number would be doubling a number. And when you double a number, you're multiplying by 2. So I'm multiplying by 2 a number. Okay, so we don't know what the number is, so we're going to give it a variable. I'm going to give it the variable y is equals negative 34. Okay, so let's write this out. So 12 decreased by twice a number, so 2 times y, is negative 34. Find the number. Well, the number is y, so find y. All right. So I need to get y by itself. So I'm going to do PEMDAS in reverse order. I'm going to subtract 12 from both sides. Okay, those will cancel. And I got negative 2y. Okay, that negative stays on there, right? That subtraction doesn't just go away. Equals, okay, negative 34 minus 12 would be negative 46. Okay, cool. Now, still getting y by itself. So we're multiplying by negative 2 here, so I'm going to divide by negative 2 and do that to both sides. So those negative 2's will cancel, so I'm left with positive y. Negative 46 divided by negative 2. A negative divided by a negative is a positive. So what's 46 divided by 2? That would be 23. So find the number. Well, the number would be 23. And you can plug 23 in and check that. You want to do that right now? Go ahead. Maybe I'm wrong. If I am wrong, shoot me a quick email. Okay. Number 2. Among the career home run leaders for the MLB, so the Major League Baseball, Hank Aaron has 175 fewer than twice the number that Dave Winfield has. Okay. Hank Aaron hit 755 home runs. How many did Winfield? Okay, so how many home runs did Winfield have? Okay, so Hank Aaron has, I'm going to see this number sentence right here. I'm going to write that out. So 175 fewer than twice the number. So what I'm actually doing is doing twice the number. So I'm going to do 2, and I'm going to use the variable y for that number. And we said 175 fewer than that. So I'm going to subtract 175 from it. Okay, so I have that in numbers, but what does that equal? Okay, Hank Aaron has 175 fewer than twice the number that Dave Winfield has. Hank Aaron hit 755. Okay, so Hank Aaron, his number was 755. Okay, so this equals 755. So how many did Winfield have? That'll be this y value. Okay. So we just have to find y. So PEMDAS backwards. So we're subtracting 175, so I'm going to add 175. And I'll do it to both sides. So that'll be 0. And I get 2y over here. Let's add those up. So 930. Let me know if I did my math wrong, but I just added those up. Okay. Still gotta get y by itself, multiplying by 2, so I'm going to divide by 2 on both sides, and I get y equals, let's see, half of 900 is 450, half of 30 is 15, so half of 930 is 465. So So y is 465. So how many did Winfield have? 465 home runs. Not too bad. Okay, so for these, the big idea is that you're able to figure out and pull out what that multi-step equation is, make the equation, and then solve it. Okay, we're going to do one more together. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. Okay, after he uses a $25 gift card, the total cost before tax is $115. What did the skis originally cost? Okay, well, we know that in the end, what we paid was $115. Okay, so we're going to say, well, it equals $115. Whatever we did, it ended up equaling $115. Okay, we need to find the original cost. So Hiroshi, when he looked at the skis, okay, the skis originally cost something, but then they were on sale for 2/3 of the original price. Okay, so to find 2/3 of the original price, you do 2/3 times that original price. Let's call that x. I don't know why I put parentheses. Okay, so that's 2/3 of the original price. Oh, but he also used a gift card for $25. So that would knock off another $25 off the price he would pay. And I think that's all the information, right? Skis on sale for 2/3 of the original price. We got that. He uses a $25 gift card. We subtracted that $25 from the cost. Total cost before tax is $115. What did the skis originally cost? Okay, we're good to go. So, PEMDAS in reverse order. Gonna add 25 to both sides. Okay, those 25s will cancel. We're left with 2/3 times x equals, gonna add these up, 140. Tell me if I did it wrong, but I think I got her. Okay, so 2/3 x equals 140. I need to get x by itself. So I need to get rid of that 2/3, but that's tripping me up because that's a fraction. So am I really just going to divide by 2/3 on both sides? That sounds like a pain. Okay, remember, when you are dividing by a fraction, what you're really doing is multiplying by its reciprocal, right? Keep, change, flip. So instead of writing it like that, keep the 2/3, right? Like, we can't change that. That's part of the equation. Instead of dividing by 2/3, multiply by 3/2. That's the same as dividing by 2/3. So those will cancel. But we have to multiply by 3/2 over here as well. Okay, so we have x equals what? Okay, well, 140 times 3/2 is like 140/1 times 3/2. 140 times 3, well, I can cross reduce here, right? 140 is even, so I can divide it by 2. So 2 divided by 2 is 1. 140 divided by 2 is 70. So I do 70 times 3. Okay, well, 1 times 1 is 1. 70 times 3, well, 7 times 3 is 21. But we're doing, one of them has a 0 after it, so I gotta add a 0. So then it's just 210. So x equals 210. Right, the original skis cost $210. Alright, so I know this was a little bit of a longer video. As always with videos, though, you can always fast forward if you're really getting it, start trying the homework, come back if you need more additional help. You can always pause it if you think you need to take your time on things. But I really hope that this was helpful with doing applications of solving multi-step equations. Right, algebra, signing off. Peace.